Hello, this is a short module on parameterization and how to do it. Parameterization is an important element of the overall goal of achieving reusable designs. I've heard many design managers complain when they go from chip to chip that is successively designed in their group, they tend to have to redo large chunks of code all over again, even though they've already done them before. For example, memory controllers, digital signal processing units, and so on. They could save a lot of time in later designs, in design and debug time, by reusing previously implemented modules. However, that is not usually just a matter of directly cutting and pasting in the previous module. Often there is some modification that's needed. To support that modification, here's some sensible guidelines on how to do that. Create a sensible structure overall in terms of the number of modules, the human readability of those modules, and the organization of those modules. Have meaningful variable names. This usually means longer variable names, but it makes it so much easier for a designer, particularly another designer, or frankly even yourself 1 year later, to understand what's going on and do the required modifications. Have useful comments. What are particularly valuable are large comments explaining the purpose of blocks of code and expressing the algorithms that are embedded in the code. It can be very hard to reverse engineer an algorithm out of the actual code. What is not useful is explaining the code line by line. This is simply stating with English what any Verilog designer can already read. Finally, heavy use of parameterization and central management of parameterization makes reusable designs easier to achieve. I strongly recommend you centrally manage all your parameterization from one place, usually in the top module. It can be even a separate file that you read in with a -include. There are 3 methods in Verilog to propagate parameter changes from a central module to the actual instance modules. The first one is defparen. What defparen does is overwrite the parameter declaration in an instance module. Notice that parameterization is referred to hierarchically with the instance name and the parameter name in that module. So for example, we have a module here, FPU unit. Inside it, we declared parameter data width equals 4. Here we're instancing 2 copies of that, one with an actual data width of 8 and one with an actual data width of 16. Obviously, all the vectors that are declared in FPU unit that are appropriate use this parameter so that you actually end up changing the details in the design in terms of the actual data width. Another way to do this is to use implicit override during instancing. In this method, you put a hash parentheses in front of the instance name when you instance the module. And so what you're doing here is again replacing data width with 8 in this instance and replacing data width with 16 in the second instance. If there are multiple parameters that you're replacing, then you have to be careful to have the order of the parameters in these parentheses in the correct same order. With explicit overriding during instancing, you don't have to maintain the correct order. In this method, you actually refer to the parameter name inside the module, .datawidth. Thus, you can have whatever order is natural for you in this hash statement that is changing the parameters when U0's instance. And again, we're changing data width to 8 and 16 in this example. Finally, here's a suggestion, and that is to parameterize the parameterization. Here again, I've got a central method of calculating the parameters I need for a particular design as that design changes from chip to chip. I do this centrally and then just pass the parameters when I instance the modules. This way, all the parameters I have to change, if I want to change, in this example, the number of entries and thus the number of address bits, I've essentially maintained in a tight piece of connected code. I don't even have to go hunting through the instances in order to make sure that the changes are done correctly. Well, I hope this module was useful to you. I urge you, particularly as you enter industry, to start practicing parameterization and writing maintainable and updatable code from the get-go. It'll make your life easier as you go along and instance your design in multiple chips. Thank you very much.